I love neuroscience, right? I'm a neuroscience nerd, self-professed, right? And I say nerd not as a derogatory term, and I'm calling it to myself, right? I just love understanding this thing, right? Let me just get hold of my little friend here. This is amazing. And sometimes you can have things that, you can get into stuff and it can be very academic and it can sort of like go over your head. But I just love how this next speaker takes that and puts it in a way that's practically understood. Dr. Sarah McKay is a neuroscientist and science communicator who specializes in translating brain science research into simple, actionable strategies for peak performance, creativity, health, and well-being. Sarah grew up in New Zealand, where she completed a Bachelor of Science with honours at Otago University, then headed to Oxford University for her PhD. She summed up her thesis with the words nature, nurture, and neuroplasticity. After 5 years of postdoctoral research, Sarah hung up her lab coat to pursue a career in science communications. Sarah is the author of the Women's Brain book, The Neuroscience of Health, Hormones and Happiness, and the director of the Neuroscience Academy, which offers professional development programs in applied neuroscience and brain health. In 2019, Sarah hosted an episode of the ABC program Catalyst, exploring brain health, biohacking, and longevity. Sarah lives in Sydney's northern beaches with her Irish husband, and together they are raising 2 surfer dudes. And we're really excited to have her as our resident neuroscientist at the People Builders Institute. And I want to share her with you right now. Please help me welcome as she comes in, Dr. Sarah McKay. Hey, Sarah.
Hello. Thank you for the invitation.
That's clearly, my pleasure.
I'm seen and heard now.
You are. It's working perfectly. So I'm going to get out of the way, and I'm looking forward to hearing about the seductive allure of neuroscience. So over to you.
Yeah, the seductive allure of neuroscience. Well, thank you so much for the invitation, Grant. Can people comment in the chat? I'm just wondering.
Yeah, they can comment, not in our chat.
Oh, not in our chat.
Yeah, so and I'll at question time I will bring some of those things for you.
So you'll let me know who they are and what they're thinking as we go along here.
Fantastic.
All right. Well, I'll just get into it. No, I should. So I do want to talk to you about this neuroscience, and as Grant has said, that has been my gig for many years. I met and fell in love with the discipline of neuroscience back in the very early 90s when I was at Otago University. No, actually, that's not true. I was at Canterbury University my first year of uni back in the early 90s, and was recommended by a psychology lecturer to read a book called The Man Who Mistook His Wife for a Hat. Probably, I usually have it lying around somewhere. Yeah, I do. By a chap called Oliver Sacks, who you may or may not have heard of. Wonderful neurologist, no longer earthside, who was absolutely very, very gifted and skilled at telling stories about the human brain and mind and what goes wrong with us when our brain malfunctions. And I was utterly captivated. So I actually changed universities to Otago University because they had a brand new degree on offer there that year in neuroscience. And it was one of the very first times this new discipline of neuroscience had been offered anywhere really in Australia or New Zealand. So this is in the early 90s. And I was the first cohort to graduate from Otago. And just from the moment I started delving into all things brain, I was utterly captivated, and I really have been. And as Grant has very nicely sort of told you a little bit about my CV, I was fortunate to win a scholarship to Oxford University, founded by the Wellcome Trust, to do a master's and then a PhD in neuroscience. I then moved to Australia. I did 2 postdoc fellowships here in Sydney at the Garvan and at Neura in Sydney, looking at various aspects of ideas kind of conceptually around plasticity, neuroplasticity. I then hung up my lab coat and moved into science communications, specialising within neuroscience. And I have done a lot within this neuroscience space, teaching online training programs in neuroscience. I've written a book. I've got another book that I'm about to start. I've written a couple of textbook chapters. I'm writing a textbook chapter at the moment. I've given a TED talk on the neurobiology of afternoon naps. I've been really kind of deeply immersed in this world of neuroscience for my entire career. A good kind of quarter of a century now. I've been working away in all of this. And look, I'm not really kind of saying all of this to talk myself up, but just to give you an idea about how long I've been working away within this discipline. And despite all of this time I have spent in this space, I am familiar with, I would say, roughly less than 1%, definitely less than 1% of all of the neuroscience literature that has been published. And of that I'm familiar with, I probably understand a very small fraction of that. I went online just before the call started to get a rough count of how many academic papers had been published containing the word brain or neuroscience within the last year. From this time last year, 123,384. And in the last 5 years, over 500,000. Look, I probably have read 100 of them, if that. Just to give you a sense that neuroscience is incredibly broad. It's an incredibly deep and rich subject. And really, been doing this for 25 years, I really believe it's only just kind of coming of age. I've seen a growing interest in the last sort of 5 or 10 years, more so the last 5, this kind of growing thirst and interest in all things neuroscience and brain. As I said, it's kind of really only just coming of age. It's a discipline that is so enormous. It spans everything from, genes, and we have genes which build molecules, which build cells, which build neurons, brain cells, which also build glia, which provide half of the, support cells within the brain. We've got neurons and we've got glia, and these wire up and connect up to form networks and systems which can produce behaviors and sensation and perception and cognition, our abilities to think and feel and behave. There's so many layers in which we can explore this topic of neuroscience. And this sort of single organ, Grant was waving his brain around. I've got a plastic brain too here. I've got one inside here as well. It controls every aspect of our body. It controls our heart rate, our sexual activity. It integrates various, parts of the world and our body and our mind and our memories to create emotions. We learn, we remember. It's integrated with our immune system to control our response to disease, and in some ways determines how well we will respond to a medical treatment or not. Ultimately, it shapes all of our thoughts and our hopes and our dreams and our imagination. It's, our brains are what make us human. Like, brains are cool. I'm a very happy nerd spending my time wallowing around in this world of neuroscience. But there's a few problems that we've got, and these are kind of what I want to talk to you about today. I don't want to come on to this talk as a neuroscientist and just, throw out a few neuroscience sounding words that you'll get excited about and may not be able to do anything with. I want to approach this from a bit of a different perspective, and one that you may not really have considered before. I want to start off with a quote from there's a neuroscientist out there called Robert Sapolsky, who says that, little can be understood about humans if we proclaim that a certain brain region or a certain gene or a certain hormone or a neurotransmitter explains everything. And herein lies one of the problems we have with trying to translate neuroscience. If we're trying to understand why we humans do what we do, and really that's generally why most people are interested in neuroscience, why are we the way we are? We have to factor in a whole lot of factors. I just talked about this sort of idea of gene to molecule to cell to network. We have to look at the neurobiological events that have taken place 1 second before a certain behavior. And the hormonal events may be from a few days before, and perhaps neuroplastic changes which have taken place weeks before, epigenetic events that may have taken place in our childhood, our fetal environment, the genes that we have gained from each parent, and you know, decades and centuries and millennia of culture and ecology and evolution. There is a whole lot we must take into account in order to understand any human behavior. So we're kind of stuck because we're busy sort of proclaiming this part of the brain does that. We have this part of the brain is the fear center, or that part of the brain lights up when we are expressing empathy for someone else, or there is a gene for depression. These very simplistic statements kind of hardly scratch the surface of this sort of this extraordinary field of neuroscience. And herein lies the problem. You know, I can kind of see this from a number of perspectives. The problem is what we're trying to do is translate neuroscience research, take it out of the lab and make it relevant to our lives. We're trying to make it relevant to the clinic. We're trying to make it relevant to the classroom. We're trying to make it relevant to, you know, the corporate boardroom, where, you know, we're trying to translate it for teachers. We're trying to translate it for health professionals. We're trying to translate it for coaches and leaderships and social workers and HR professionals. You know, we're trying to go from brain scan to classroom lesson plan. And I'm not convinced that we're quite there yet. This idea of translation, this even going from, you know, the lab bench to the bedside, which is a pretty tried and tested, you know, translation pathway, is really, really, really difficult. It takes a really, really long time. The complexity that we have is we've got the brain, we've got the sort of state of affairs, and we're trying desperately to translate it into something meaningful. And sometimes I think we've been a bit premature. I said neuroscience is only just kind of coming of age, and we've got, you know, there's a real legitimate desire. We've got policymakers, we've got politicians, we've got people who are really interested, and rightly so, to use scientific evidence to inform policy. We need evidence-based policy. That's pretty clear. I don't think anyone can argue with that, especially within the space such as mental health or education, coaching, trying to help people. But the problem has been that there has been such enormous enthusiasm for this that people, you know, have almost kind of got a little bit ahead of what neuroscience can do. It's almost as if we're asking so much. You like to see we're going from brain scan to classroom plan, and there's a big gap in there still. And the gaps are kind of where I've spent a lot of time in the last sort of 5 or so years. As Grant said, he got to know me because I teach an online professional development program in applied neuroscience and brain health, and I saw that this was a really important space that needed to be filled. And we see this, we've seen it time and time and time again over many, many years and in many, many disciplines, this problem of trying to translate a particular discipline, particularly within science, into something that's really real and usable. We've got complex science, we've got an urgent desire. It's only understandable that we want to do that. But what happens when we have a gap? I mean, what do you do if you've got a gap? You fill it with polyfiller or blue tack or something that kind of does the job, and it looks like it'll do the job, especially if you kind of paint over it, you know, you're kind of masking the gap. But what I think it would be nicer to do was to sort of start with a really solid foundation in ways that we can, you know, confidently engineer that gap instead of just filling it with gumph. Because what I've seen over the years, particularly within the neuroscience space, and it is why I have been so compelled to do what I do, is that we have these gaps and they have become filled with waffle, with fads, with bandwagons, with mediocre grey-haired American gentlemen of the brain who see business opportunities, ways to make some money by packaging up science prematurely into self-help. and they, what I like to call, doing a little bit of neurosplaining. And there, you know, there's some real issues here. We've got plenty of businesses out there that have been packaging up brain training, you know, online brain training. And for many years there, they were claiming that you could, you know, sit down when you got home from work after a tough day, pop on the computer, do a little bit of brain training game and not get Alzheimer's disease. Well, that idea was quickly dismissed once we found that it was entirely lacking in evidence. The claims were completely overblown, and many companies were fined and stopped marketing their products in the same way. We have these concepts of brain gyms which have been rolled out unwittingly to thousands of schools around the world, claiming if only children spent more time crossing their arms and limbs, they would be able to learn with such greater ease, which again has been utterly and entirely debunked, and many millions and millions of dollars have been wasted, and time on educating children has been wasted with these dubious claims which have been packaged up. There's you know, claims out there that, you know, if you can only change how you think, tapping into neuroplasticity, perhaps you can even improve your income. Now, look, before you think I'm on some kind of snobby academic soapbox alone here, these problems have been very, very well addressed, and they have actually been very well examined and addressed within the academic literature. This kind of world of gap filling out there has kind of led to, and in turn has been propped up by a couple of really big problems within this field of neuroscience. One of them is this idea of neuromyths, and the other idea is the seductive allure of neuroscience explanations. Now, neuromyths have a specific definition within the research space. Neuromyths are a field of research in their own right. I've just downloaded a few papers here, just so you don't think I'm, as I said, having a little personal rant about this. Paper here, Neuromyths in Education, Prevalence and Predictors of Misconceptions Amongst Teachers. So we have academic literature around this concept of neuromyths, and we have this wonderful and fascinating literature called The Seductive Allure of the Neuroscience Explanation. And got a couple of papers here which I'll talk through. So this isn't just me having a little personal rant as a neuroscientist. I thought it would be really interesting, as I said, let's approach neuroscience from a bit of a different way for you all this morning. Let's take a look at some of the academic literature around neuromyths and the seductive allure of neuroscience. So neuromyths are really misconceptions about this has a formal definition that neuromyths are misconceptions about the brain that are either not yet supported by the data or have been actively contradicted by the data. So there are these ideas about the brain which either not yet proven or disproven, yet permeate the public imagination. Seductive allure of neuroscience explanations, you know, almost that particular phrase, and it gets rather entertainingly, I think, turned into an acronym, SANE, SANE, Seductive Allure of Neuroscience Explanations, also has its own specific definitions and has a growing interest in research around it. It's been kind of going on for a bit of a decade now. The very first paper that was published in this space is kind of like the I suppose the classic of the space. Is actually first published back in 2008 by a group from Yale University led by Dina Weisberg. And they've first published in kind of this particular phrase, this seductive allure of the neuroscience explanation. And they set out to try and explore why people are more likely to believe a particular explanation about human behavior, particularly some psychological explanation about why humans do what we do, is either more impressive sounding, is more relevant, is more believable, or is more actionable if neuroscience is added in there. And so they created a number of circular arguments or a number of long-winded explanations which included neuroscience or didn't, or made a lot of sense or didn't make sense, in order to sort of test out what people kind of took away from that. And they might have had a phrase, for example, humans like dogs. I've got a dog here on the floor next to me, sound asleep. He normally comes and says hi in the middle of a talk somewhere. What? Do you want to come and say hi? Hey, completely asleep. Oh, he's moved his head to look at me. I like dogs. Everyone loves, most people love dogs. Here's one of these sort of circular arguments I had. Humans like dogs because we have a strong preference for domesticated canines, which if you apply a little bit of critical thought is meaningless. We like dogs because we like dogs. Humans like dogs because our parahippocampal gyrus in the brain lights up when we interact with canines, signaling to us that we feel pleasure. Again, we like dogs because a region in our brain indicates that we like dogs. There were a number of different arguments and different statements that were made along these lines. And essentially what the researchers concluded was that when a neuroscience explanation was added in, people found it satisfying, they found it believable, they found it actionable. They were far more likely to believe that it must be true, even if the statement was senseless. Humans like dogs because we like dogs. A second paper was published reasonably soon after that, exploring this similar idea, the seductive allure of the neuroscience explanation. But this was called Seeing is Believing, the Effect of Brain Images on Judgments of Scientific Reason. And again, similar kind of approach, but again, someone might be talking about humans like dogs because they like dogs, but it was done with a large image of a brain behind them, or in particular, a brain imaging image, an fMRI or an MRI image of the brain. And again, people were far more likely to believe what was said was true, were far more likely to be compelled to act or agree with the particular statement if there was an image of the brain there. Now, over time, there was some inevitable pushback, and this is often the case. I mean, the seductive allure of the neuroscience explanation is a pretty exciting sounding research field, and that's kind of been, tinkered with and passed down now. And there's a paper that came out, the selective allure of the neuroscience explanation, and the seductive allure of neuroscience. The seductive allure is a reductive allure, and so it goes on. But essentially the findings, even though they kind of went back and forward a bit, have kind of landed in the same place. And rather interestingly, and perhaps disturbingly, depending on your approach, one study even went so far as to look to see how much on very serious issues, social issues, one on the death penalty and the other taking a look at abortion, found that if neuroscience explanations were provided as justifications or not, people, depending on a person's attitude, for example, towards the death penalty, they would believe the neuroscience and give it a far more favourable rating if it supported their personal attitude to the death penalty. If their attitude was that the death penalty was inappropriate, then they were far more likely to denigrate the science. And similarly, attitudes were found around abortion. So we can see, even when we're starting to dig down into quite serious social issues here, the presence or absence of a neuroscience explanation can be incredibly compelling. And we're starting to see it sort of seep into the justice system, whether or not people should be, sentenced at a particular age based on what we understand about brain development. And it has some really serious implications beyond just, some neuroscientists like me going, well, you shouldn't just believe everything that you hear about the brain. I mean, in short, what this means is people like neuroscience explanations, even if we don't need them. Now, I believe there are some upsides to this, not just this dark side of showing an interest in neuroscience. So if you are a person that helps other people, if you are a teacher, if you are a coach, if you are a leader, if you are in some way working with or helping, other people understand a little bit more about who they are and why they think and feel the way they do, perhaps you're interested in yourself, perhaps it's your children, perhaps it's parents, perhaps it's just, kind of taking a look out at, what's happening in the world right now and why people behaving the way they are. If we can, in some way, what can we kind of take from this idea of this seductive allure? And I'll say this is a bit cheesy, it comes from a Spider-Man movie or something, but it can be like a superpower. The ability to talk about neuroscience in a really clear, informed way can be a superpower, but you've got to use it wisely. Like any superpower, if you're going to seduce people in with this allure, you've got to use it wisely. We can use neuroscience in 3 really powerful and useful ways. We can talk about basic neuroscience concepts. We can talk about neuroplasticity, how that is involved with things like synapse proving, the removal of unwanted connections in the brain at different stages of development. And that can give us some insights perhaps into childhood brain development that could maybe translated into the classroom. We could talk and understand about how neuroscience is done, how scientists figure things out. And I have to say 2020 in particular has been a fantastic lesson for people outside of neuroscience or outside of science in general as to how the scientific method is done. We've seen science live streamed during 2020 in terms of the exploration of this pandemic. People have never seen science live streamed. They've never seen the shades of grey. They've never seen how data can inform or misinform and how policy decisions have to be made based on perhaps uncertainties of that and how messages can be switched almost based on new data coming in. It's been a fantastic lesson into how science has been done this year. So we can talk about neuroscience concepts, we can talk about how neuroscience is done, and we can talk about how we can apply these ideas from neuroscience. But as I've said, this is quite tricky. Now, this idea of talking about neuroscience, there are some spaces in which this has been tested out and shown to be useful. And if we're going to be doing it, we better be doing it with wisdom and thought and care. One space in which this has been done particularly well and has been tested, one of the few places, believe it or not, in which it has been tested is within mental health, particularly in this space of what we call psychoeducation. So a method that it's like an adjunct method. It's a extra tool that we can use for helping people dealing with mental health issues, with mental illness. So it kind of blends a psychotherapeutic approach with a cognitive behavioural approach, and that we are giving people the tools in which perhaps you've got anxiety, serious anxiety. Everyone's a little bit more anxious this year than normal. I am myself, despite knowing a bit about how the brain works. A psychoeducation approach to anxiety would be to give people perhaps tools in which to, challenge their thoughts and resultant feelings and behaviours, but also teach them about how the brain perhaps responds to threats and challenges and opportunities, and how that may be integrated into a stress response, and when a fear response may be appropriate or not. Now, this has been pretty well tested, and if this educational approach to talking about the brain is used alongside a particular therapy, we can see it aids in the process of recovery. Now, this is one of the few places in which we have any good clear evidence that talking about neuroscience works. It is one of the few spaces, if you are a real stickler for doing this in an evidence-based way, this is one of the few places that talking about neuroscience has been tested and has had an outcome. And so what have we seen? We see people, gain a more extensive understanding of their habits and perhaps their automatic responses to events. For children, young people, it can help stimulate kind of curiosity and interest in themselves. And it often helps people depersonalize some of their responses. It helps them kind of go, okay, this is happening in my brain and body and nervous system. And it gives them the ability to kind of place almost a biological framework in a way around that and step back and take a bit of a look. So it has its uses. Interestingly, as I said, one of the few spaces in which talking about neuroscience has been tried and tested. Classroom, we're not really seeing much. Coaching space, we're not we haven't seen any work done in that space at all. What are some of the downsides, though, if we're going to, start plugging these, ideas about the brain? For me, one of the major risks that we see in this space and has been explored in terms of the seductive allure of the neuroscience explanation is just, quite frankly, lack of education. Lack of neuroscience education, and of course that is not the reach of most people. And I'm in my mid-40s. Neuroscience wasn't even offered as a type of degree until I was in my 20s. We have a lack of science literacy in general, particularly children coming through school now. They're doing a cracking job in education, particularly here in Australia. My kids' science literacy, understanding the scientific method, it's not just a collection of facts, it's pretty good. There's a lack of critical thinking in a lot of the general population. Kids are being taught this now, which I think is really encouraging, but kids aren't the ones that are using this stuff yet. They're not the ones making policy decision. They're going to be able to really, my 10-year-old isn't going to be able to influence much, for a good another, 10, 15, 20 years, if that. Might be too late. Who knows? So we don't need to just teach this stuff at schools, okay? It needs to be the basis of a lot of work that people do within broader education, within broader coaching, training, in the work they do. Even these basic ideas of teaching critical thinking skills and understanding the scientific method, you pick up any basic psychology textbook these days, it will be in there. So that's one problem. We've got a real gap in people's knowledge and education. And because of this, we have this infuriating reliance on these fads, these brain gyms, these, ideas, and a lot of older ideas that, perhaps make intuitive sense but have no basis, or have been disproven. And there's also a bit of a criticism in the space that, neuroscience hasn't actually really led to any new methods yet, even within mental health. One of my best friends from early childhood is in New Zealand. She's a psychiatrist. I'm a neuroscientist. And as she says to me, well, I don't need a brain imaging to tell me if a treatment works. I just ask the patient how they think and feel. We don't need to be always peering inside the brain. So this misuse of these neuroscience explanations has, propped up, and kind of we end up in this vicious cycle. We've still got these neuromyths. So I just want to touch on some of these neuromyths briefly now, because I'll be really curious. I can't see the comments. I have no idea how you're all responding to this, but I'm not sure whether these ideas are those in which you believe. The research that has been done into belief of neuromyths, these ideas that have been disproven or not yet shown to be true, have been classified, and there's a core group of sort of 7 or 8 classic neuromyths, which people by and large believe. Over 50% of people in the population typically believe. One is this idea of learning styles, that we all have a different learning style, and if only we taught someone in the appropriate visual or auditory or kinesthetic way, they would learn better. That has been disproven, and it is perhaps one of the most believed myths about the brain. This idea that physical movement coordinates the left side and the right side of the brain. We have another left brain, right brain. We have left brain or right brain learners, or ways of thinking. You are either a creative right brain person or an analytical left brain person. Again, we have zero evidence. In fact, we have many studies disproving that. We have I think it's falling out of favor a little bit now, the Mozart effect, the idea that listening to classical music will help you concentrate, or even, playing classical music to an unborn child will make it smarter as its brain wires up. Again, disproven. Another really popular myth, and I see this, I try and ignore parenting commentary now. My boys are getting old enough, I'm trying not to buy into it, this idea that sugar causes hyperactivity and lack of attention in children. Again, we have no evidence for that, believe it or not. And then perhaps the most well-known myth of them all, and I get asked this often, we only use 10% of our brain. So they are these 7 classic neuromyths, tried and tested within the academic literature, and a good 50%, give or take, of people believe at least one of these to be true. Most annoying to me, however, and Grant will probably nod his head and be familiar with some of these with me, by far and away, the story about the brain, which annoys me almost more than any, and I am on my soapbox about this, but I'm not alone, is the idea that we have a reptilian brain or a lizard brain lurking deep within us, which kind of guides all of our behaviors and overrides our critical mammalian ability to think and make decisions. I'm happy to discuss that in more detail if anyone wants to later, but I've got a blog post talking about why I think we need to rethink the reptilian brain. No neuroscience textbook that has been written within the last couple of decades mentions the reptilian brain, unless it is to say it is a load of neurobunk. Here's another one that kind of is perhaps just because this is a real sort of subtle idea out there, that neurogenesis, the birth of new brain cells, helps us learn. That's not how the brain learns, believe it or not. Perhaps doesn't get me as riled up as the old lizard brain myth does. But there's another myth. It's not really necessarily a myth, but it's a way that we talk about the brain, which isn't necessarily true, that each part of the brain has a particular function and lights up when it is performing that function. And again, we have moved far away from this idea of functional localization, particularly for most of our more complex behaviors and thoughts and feelings within the brain. Now, if we kind of get back to the nitty-gritty academic literature, you know, how these factors and myths have emerged and proliferated has been, you know, these ideas have been identified. And number one is this idea around education, lack of critical thinking, the inability to be able to take a look at these basic science questions and then make that accessible or relevant into that space. You know, lack of professionals and professional organizations who are working within that polyfilled gap. Instead, as I said, we've got the mediocre American gentleman of the brain packaging things up and you know, flogging it to everyone. And again, this is propagating all of these ideas. By and large, and essentially, we underestimate how complex this space is. We underestimate how complex human behavior is. And we just want these simple answers. So I'm not going to bang on anymore about all of these ideas, which you may believe, which may not be true. I'm just going to make one very, very strong recommendation, and then I'm going to give you a simple tool that I want you to take away from this. My one strong recommendation is, if you are interested in learning about the brain, if you are interested in learning about neuroscience, try learning about it from a neuroscientist. There are a lot of neuroscientists, neurogurus out there. If you are a teacher wanting to learn more about education, you probably learn about it from people working within teaching, within education, you know, within educating educators. You know, if you're a doctor wanting to specialize in cardiology or, you know, dermatology, you're going to go to the experts within that space who work, learn, research, and teach within that space. If you're a coach and you're wanting to gain qualifications, I imagine and I hope that you would go and learn from people qualified, working and teaching within this space. Please don't go and try and gain your neuroscience education from someone who talks about quantum theory and relates that to synapse plasticity and somehow links it up to the universal consciousness and wraps it up in a pseudoscientific, fluffy spiritual bow, and then delivers it with the confidence of these blokes over in the US. There are some recommendations. I have some recommendations for you, and I can provide these in writing, maybe to Grant if anyone wants them. There is one neuroscience adjacent gentleman that if you work within the space of mental health, education, coaching, therapy, psychology, I recommend you meet. I know all of these people personally. John Arden is one of them. He has written a couple of really interesting books, one in particular called Brain to Brain. Now, he's not a neuroscientist, but he is a psychologist, therapist, and works in a very legitimate, thoughtful, and caring way within the space. So you can follow him. my old mate, Andrew Huberman, who is absolutely smashing social media and neuroscience education at the moment. He's a professor at Stanford. We first met when we were doing our PhDs many, many years ago. And he does an absolutely exceptional job, especially via Instagram, on educating people about neuroscience. Sarah Jane Blakemore is a researcher. She's just moved from London to the University of Cambridge. Her father was actually my PhD thesis examiner, Colin Blakemore, and she works within the space of child and adolescent neuroscience. And she's she's sort of the doyenne, the sort of the founder of this space of adolescent neuroscience. Again, an exceptional person to follow, thoughtful, particularly within the space of education. And Lisa Feldman Barrett, who has an exceptional book that came out a couple of years ago called How Emotions Are Made, and has a brand new book coming out in another few weeks. I think it's something like 7 facts about the human brain. And I was delighted to see that one of those chapters is devoted to debunking ideas around the reptilian brain. And all of these people do a lot of work within neuroscience education outside of the research that they do. They're exceptional communicators. They're thoughtful, and I believe that you can trust them, the neuroscientists. If you want to learn about neuroscience, go and learn about it from a neuroscientist. If you're kind of slightly out of that like neuroscience space, Caroline Webb is a woman from the UK who does a really wonderful job within the coaching space, kind of combining behavioural economics and organisational psychology and neuroscience. And she's written a book called How to Have a Good Day, which I think is excellent and thoughtful and wise. Now, what I want to do is I actually want to give you something that doesn't make you feel deflated for someone who's been trying to talk about neuroscience or think about neuroscience or learn about neuroscience for a while. So you're completely, scared off wanting to do any of this ever again. I'm going to sort of introduce you to this really simple model. Grant will be familiar with it. It's called bottom up, outside in, top down. And what it does is give you a kind of a framework in which to think about the complexities of the brain, because, this quote I gave you at the beginning of this talk and this idea I've taken from Robert Sapolsky is, we need to be considering events, neurobiological events, endocrine events, neuroplasticity events. We've got all these, the brain is kind of this prediction machine that is pulling in data from a load of different sources, and then predicting and making best guesses about what to do next. And this framework will give you a bit of an insight into that. So I'm just going to share. I think I can share my screen just to give it a bit of, just show you how complex this stuff is, and then give you this framework. I always find this really, we talk about is there a genetic predisposition to Alzheimer's disease? Here's a diagram looking at all of the genes that have been identified and involved in something like Alzheimer's disease. And I mean, that's not even taking into account lifestyle factors. These are just genes involved in Alzheimer's disease. So, none of us have got any hope. Can't even scratch the surface of that literature. Here's a reasonably new update on various stress response pathways in response to something as simple as a physical threat, bleeding out, extreme heat, extreme cold. We're not lizards with fight or flight responses. There's a lot of arrows there. We're interested in, wiring diagrams around the brain and motivation pathways and happiness and pleasure. And we know that there's this dopamine neurotransmitter involved. Well, here's what we would call a wiring diagram of a single dopamine neuron in the brain. So again, there's a lot going on. Okay, we're dealing with really super complex systems here. We can't make simple statements. What I would like to do is introduce you to this idea of considering anything within neuroscience, anything about the brain. It's complex. Here's a framework in which you can sort of start trying to consider the various inputs. All of this, the brain is a prediction machine. It's pulling in data from a lot of different places, and it's kind of, computing what it's going to do next. There's information coming in from our bottom-up biology. Our brain sort of sits within our skull, inside our brain, and there's information coming into the brain that is determined by our bottom-up biology. You know, our genes, we've talked about, you know, our genes, our hormones, and they could vary depending on your age, your sex, time of the day, time of the month, time of the life, male, female. We've got hormones, our immune system. People are probably thinking a little bit more about our immune systems in 2020, I think. You know, we've got signals coming in from our gut, and people are getting really excited about these gut-brain interactions and the microbiome within the gut. Again, more data, more signals being received from the brain, the food we're eating, how we are moving our bodies around through the world, you know, how we're even using our muscles. Muscle strength, muscle integrity is related to cognitive fitness. You know, how we're sleeping our body. Okay, so the brain's receiving all of these signals from the bottom up, super complex. It's also moving through the world and receiving all kinds of signals and information and data from the outside in. Who are the other people that we've surrounded with, you know, who are in our immediate families and our extended social support networks? Who can we see? Who can't we see right now? Who's far away? Who have we been interacting with? You know, what was our relationships like in our early lives? You know, what were these social signals we were receiving from early childhood? What external stressful events are out there, these kind of immediate stressful events or threats that may be right in front of us, you know, a car horn tooting that might give you a fright versus this kind of existential threat that we have at the moment from this pandemic. You know, we've got all these life events which are happening to us all the time, and these previous life events we've had as well, even the education that we've received, and of course the interactions that we have with the natural world, with our light-dark cycles, with moving our bodies through the natural world and interacting with that. So we've got a lot of outside-in data coming in through our nervous system, through our eyes, through our retina, which is just an extension of the brain, into our ears and the sounds we hear, the food that we're taking into our bodies, you know, what we touch and feel and sense. There's a lot of data from the outside world coming in. And then our brain itself, this is a bit of a harder kind of slippery ball to hold on to, is also receiving data and input from itself in a top-down fashion. Our thoughts and our feelings are cycling between different networks, our mindsets, our beliefs. We can always kind of sometimes put a thought or a feeling or a belief like right here in the middle and go, what influenced that thought from the bottom up, from the outside in, from the top down? Why did the brain predict this emotional response in this situation based on the signals from our body, what we were feeling inside our body, and the situation we were in, and our top-down perhaps experiences or memories of that? So just to give you some examples of how I use this model and how you might use it in a way that might give you a bit of a brain framework, a neuroscience framework to think about really complex ideas. Let's put something in the middle like depression. People are really interested in depression. What makes depression? What causes depression? Now, depression comes in many, many shades of blue. Why might someone fall somewhere in the middle of one of those shades of blue? You know, what were the signals from the bottom-up body? Were you genetically predisposed? Is it a particular hormonal issue? You know, the withdrawal of the good hormones from pregnancy and those early weeks of motherhood. Have you got some kind of immune, you know, reaction going on in your body? Are you not eating the right food? Are you not sleeping? Have you not exercised in a while? Those signals will be contributing to depression. Outside in, is some external stressful event triggered something? Have you lost someone you love? Are you separated from someone you love? Has there been some incredibly stressful life event, a divorce or job loss perhaps? And then we've got these top down, perhaps disordered thinking. Perhaps we need a cognitive behavioral approach to readjust a response to an emotion. So we can put something like depression in the middle of this model, think about it in a neuroscience context, and then break down all of these various interacting factors. We could do the same with something like insomnia. You know, perhaps you need a bottom-up, outside in, and top-down approach. You need to work on your daily exercise, honour the light-dark cycle from the outside in, perhaps reassess some of your attitudes to waking up at night. We could also look at ways to buffer an external stressful event, perhaps by ensuring we have enough sleep, by connecting socially, and by perhaps, you know, thinking about a previous time or a memory we've had in which we were able to manage stress. So this and the same for Alzheimer's prevention. I don't want to kind of belabor the point. But as I've said, this is an incredibly complex space. There are some people who are doing some really good work in here. We need to just sort of approach this wisely, not get seduced by complex ideas, trying to oversimplify them, and perhaps learning from the people who are filling the gaps with what we call these, seductive neuromyths. So, as I said, I work within this space. This is kind of really my life's work, and I'd like to challenge you and encourage you to not be swept away on a wave of neuroscience excitement, but to approach it in a bit more of a thoughtful way, because we really should be doing the science and the scientists justice. So thank you very much.
Wow, fantastic. Thank you so much, Sarah, and everyone now understands why I call you our resident neuroscientist, because I love how you can just take things that are complex and bandied around and put them into simple frameworks so that we can practically apply them. That top down, bottom up, outside in is just an amazing model to be able to, just like you showed us there, take a particular subject and go, well, how does neuroscience apply to that? Rather than just have all this stuff out there that people are saying. So there was a question here I just want to go to first. Barbara says, is one of the myths that exercise does not help us learn, or did I mishear that? So can you just help Barbara with that one?
Exercise does not help you learn. Going for a run won't make it easier for a child to come back to the classroom and be able to learn how to solve a maths equation. But exercise is really good for promoting brain health and providing the right scaffolding for a healthy brain to be able to interact with the teacher and then perhaps take on board, this new technique which has been taught around solving a maths equation, for example. So again, there's kind of a few steps in here. Sending a kid out for a run at lunchtime won't help them learn maths. You've kind of got to take a step back and take a bit more of a holistic approach to that, because what the problems that have come has been, we have gone into the classroom and taken this idea and misappropriated it. And the whole brain gym franchise, which is a global disaster, quite frankly, in terms of neuroscience, has promoted this idea that if children are crossing their limbs, they are exercising their brain and the brains are then learning. That's just simply not the case.
Fantastic. Thank you for helping Barbara with that. Yeah, so look, some of the things that you were saying there around, the neuroscience in coaching, I totally agree. And that's why you and I have, started working together, because, yeah, you're right, learn neuroscience from a neuroscientist. I mean, how profound is that? That is, here in Australia, this won't translate everywhere, but here in Australia for many years, we used to have this joke where we said, hey, if you want to learn something, just go down to the pub and ask one of your mates, because you'll always find someone that will give you an opinion on stuff that they know little or nothing about. And that's part of the human condition. Yeah, so look, I've taken this quite seriously in the coach training that we do, and making sure that we don't do what I did years ago. I would learn something from someone like you and go, oh, I could just take that and apply that, and putting it in the wrong context totally takes it out of what it was designed to do. So that's why, we're glad now that we have access to what it is that you teach in the People Builders Institute. So yeah, the myths are all great. That I don't know if you could see my face in the little screen above you, but when you were going like the reptilian brain, it does my head in, and this left and right brain dominance. There's still people out there that are teaching that stuff. I remember being at I know I've told you this, Sarah, I think I have. I remember being at an event, and I went there to this event to be introduced to someone that was going to be very influential for me. And I forewent doing that. I just forgot about why I was there, because I had this young lady, I was talking to this group of emerging leaders in this large management firm. And she said, oh, I was going to be a leader once, but then I did my Myers-Briggs and it told me that I wasn't. And it was like, hello, this stuff out there is so damaging to people's careers. So I love how what you've taught us there in that model in particular at the end is a framework for us to be able to go in this current situation, we could use that as a filter for the information that's coming in, and to be able to put some, some truth around what it is that we might be thinking. So I really want to thank you. I'm just checking again if there's any other comments. We've had a bit of a challenge with the chat. I've learned something out of that as well. But if people do have questions, as I've told them, the easiest way is just hit reply on any of the emails that my team sent you or my system sent you to give you the links and whatever. Ask me a question. If there's something that you want, I'm going to speak to all the speakers and see what I can get from them. It is their IP, so I'm not making any promises on their behalf, and then I'll make that available to you. So thank you once again, Sarah, for being the amazing person that you are. I was a bit disappointed that your dog didn't jump up, or one of your kids
he's a bit tired. It's a bit tired out. He normally does. Come here. Hey, come here.
So
no, he's absolutely zonked. He's had a hard morning,
He has, the poor thing.
Yeah,
so let's give Sarah a big round of applause, everyone. Thank you so much once again. And look, we can help you to get in touch with Sarah's work. So just let us know if that's something that's really of interest to you. If you want to join us.
If you want to learn neuroscience, learn from a neuroscientist.
Exactly. I love that. All right. So we're going to go to a break right now. We're going to thank you, Sarah. We'll catch you again shortly. And we're then going to come back with the amazing Deborah Thurley. So let's take a quick break and I'll see you soon.